Very good morning to all of you students. Welcome to the mathematics class. In this session, we will study a most important chapter and the name of chapter is matrices. Student, this is a very simple and scoring chapter because from this chapter you will get two questions in the board examination. One is a long question and second is a short question. That means you will score at least 10 marks from this chapter. That's why it is the most important chapter according to your syllabus. Okay student. So starts chapter number 3 matrices. So first of all, I want to tell you what is the meaning of matrix. Student, a matrix is an ordered rectangular array of numbers or function. That means you can say that matrix is a combination of some functions or numbers which are arranged between two rectangular arrays, means between two lines, and it form a rectangular shape. For example, A is a matrix and there are some numbers like 2, 5, 7, 4, 8, 6, 3, 1, 0, 5, 2, 7 are arranged between two lines, so it form a matrix. Now the horizontal lines are represent rows and the vertical lines represent columns, and all the elements which are present between two lines are called element of matrices. Okay students, now we will discuss the type of matrices. First, row matrix. So a matrix which contain only horizontal line is called row matrix. For example, row 1 contain elements 2, 5, 7, 4, so it will be set to row matrix. In the same way, 2, 8, 0 contain one column, so we can say that it is a column matrix. Now, order of matrix. How can we find the order of matrix? So if any matrix is given like A is equal to 5, 2, 3, 1, 8, 6. Then in order to find the order of matrix, we have to multiply number of rows into number of column. So here there are two rows, that means two horizontal lines, and three vertical lines, that means three columns. Then the order will be 3 into 2. Sorry, 2 into 3 because two rows and three columns. Okay. So type of matrices, first matrix is column matrix. A matrix which contain only one column, that means only one vertical line, is called column matrix. For example, A is equal to 2, 0, 5. So it is an example of column matrix. Now, row matrix. A matrix having only one row is called a row matrix. For example, A is equal to 3, 1, 7. So it is an example of row matrix. Now square matrix. If any matrix contain number of rows equal to number of columns, that means here two rows and two columns are present, that means it is an example of square matrix, because we know that in the case of square the length and breadth will be same. Okay. Now student, diagonal matrix. Diagonal matrix is a matrix having all non-diagonal elements as 0. It means that only diagonal elements will be not 0, and except these elements all elements should be 0. So we can say that it is an example of diagonal matrix. Okay students. Now scalar matrix. Scalar matrix, in this case the diagonal element will be any scalar and they will be same, and other non-diagonal elements should be 0. So A is equal to 2, 0, 0, 0, 2, 0, 0, 0, 2 is an example of scalar matrix, because here all diagonal elements are non-zero and they are equal. Okay students. Now identity matrix. In the case of identity matrix, diagonal elements should be 1 and other elements should be 0. So it is an example, A is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1, and its order is 3 into 3. Okay student. Now zero matrix or null matrix. If any square matrix contain all the elements 0, then we can say that this is called or null matrix or zero matrix. Okay students, got it? Okay, now we will study here equality of matrix. That means in which condition two matrix said to be equal. So if corresponding elements of any two matrix are equal, then we can say that they are equal matrix. That means all the elements all the elements which are corresponding to each other, they should be zero. In this case we can say that this is equality of matrix. On this concept we will study, we will solve one example here. See students, example number 1, find the values of x and y if 5 2 comma minus 3 1 x plus y 3 2 4 is equal to 15 7 minus 12 and 11. So here in first half there are two matrices in the addition form, and in the right hand side another matrix. So first of all we will add left hand side, and after that if two matrices are equal then their corresponding parts will be equal. That means we can write here, on adding we get 10 minus 15 5 5x plus y 3 2 minus 4 is equal to 7 15 minus 12 7 11. So on adding we get 10 plus y minus 12 upon 7 5x minus 4 will be equal to 15 minus 12 7 11. Now here if two matrices are equal, that means we can write here 10 plus y will be equal to 15. This is first equation. In the same way 5x minus 4 is equal to 11. So on solving these two equations we get easily the value of x and y. Okay students, now student, we can construct any matrix if their information is given. For example, there is a condition is given a ij is equal to 2i minus 3j, and here we have to construct a matrix of order 2 into 3. That means 2 rows and 3 columns. So total number of elements should be 6. So here we can put I is equal to 1, j is equal to 1. So we will get a 1 1 like this. If we put I is equal to 1, j is equal to 2, we get 1 2. In the same way 2 1 2 2 3 1 3 2 3 3. So these are the elements by putting all the values. Okay students, so on the above discussion you can solve the questions of exercise first. Okay students, so this is your homework. You will solve the questions of exercise 3.1 and 3.2. Okay students, now we will discuss here operation on matrix. That means there are number of operations which can be applied on the matrix, like addition of matrices. So how can we add two matrices? So in order to add any two matrices, we have to simply add their corresponding elements. That means 2 will be added with 6, 5 with 4, 7 with minus 5. So by adding corresponding elements we will get the required addition of two matrices. Now in the case of subtraction of matrices, so in the same way as addition we can also subtract two matrices by their corresponding elements. Now student, properties of matrix addition. First, commutative law. In the case of matrix addition, commutative law follows. That means if we add any two matrix like A plus B, then it will be equal to B plus A. That means in the case of addition, matrix follow commutative law. Next one is associative law. In the case of addition, associative law followed by matrices. Now existence of identity, additive identity. That means if we add any matrix with zero matrix, then there will be no change and the required solution will be A. That means only matrix A. In the same way, existence of additive inverse. So if we add any matrix with the same matrix with opposite sign, then we always get a null matrix, that means zero matrix. Okay students, multiplication of matrices by a scalar. It means that if we have any matrices in any order and we have to multiply this matrix by any scalar, that is any constant number, then the all elements of this matrix will be multiplied by the same elements. This is the function of scalar. Okay students. Now properties of matrix multiplication. This is important. First property, matrix multiplication is not always commutative. It means that in the case of multiplication, it is not necessary that A into B is equal to B into A. That means we can say that matrix multiplication not follow commutative law always. Second one is matrix multiplication is associative. Matrix multiplication is associative. That means if we multiply A into B, then multiply C, and if we multiply B into C and after that multiplied by A, then it will be equal. Now, matrix multiplication is distributive. As it is associative, in the same way it is also distributive law. Means it follows distributive law over addition. That means if we add two matrix B plus C and multiply it by matrix A, then we get A into B plus A into C. Okay students, so on the basis of above discussion, you can solve exercise 3.2. So this is your homework. You solve as much as possible questions from this exercise. Now student, we will discuss here important topic, transpose of a matrix. So if we have a matrix and if we convert the row into column and the column into row, then we can say that the matrix convert into its transpose form, and this process is known as transpose of a matrix. So matrix A dash is the transpose of matrix A. Okay students, there are some properties of transpose of matrix. A dash whole dash A, that means if we find the transpose of any matrix and after that again find the transpose, then we will get the original matrix. Now K into A, that means multiplied by any scalar to any matrix, and after that taking the transpose, we get the transpose of matrix A multiplied by the same scalar. Now in the case of addition of two matrices, we also apply transpose, and it will be individually transpose of both two matrices. In the same case, in the case of multiplication, A, B whole dash will be equal to B dash into A dash. Okay student, now we will discuss here symmetric and skew symmetric matrix. So if we have a matrix A is equal to 2, 5, 1, 5 minus 3, 7, 1, 7, 2, and if we want find symmetric, then we simply transpose the matrix, and on transposing the matrix, if we get the original matrix, that means there will be no change take place, then we can say that it is a symmetric matrix. And if we get the negative sign of original matrix, then we can say that it is a skew symmetric matrix. Okay students, now student, you can solve exercise 3.3 on the basis of above discussion. So you have to solve exercise 3.3. This is your homework. Now students, next topic is elementary transformation of a matrix. Student, this topic is most important because generally this topic is asked in the board examination as a long answer. So in the case of elementary transformation of matrix, you have to find the inverse of any matrix. So by applying operation on the rows or the column, you can convert any matrix into identity form, and this process is known as elementary transformation of matrix. And you will discuss the same topic in the next chapter, determinant, deeply. So we will discuss there the process and the function of finding inverse of any matrix briefly. So student, do exercise 3.4 on the basis of above discussion and revise the whole chapter and do as much as possible questions. Okay student, thank you very much.